DeepSeek, and Chinese AI open source model that claim to be outperforming OpenAI, Google, and Meta. Today, we dive into the groundbreaking research paper by DeepSeek, which introduced DeepSeek R1. The paper title is DeepSeek R1 Incentivizing Reasoning Capability in Large Language Model via Reinforcement Learning. In this video, you will get one high-level overview of the DeepSeek R1 paper. DeepSeek recently introduced their two reasoning model, DeepSeek R1 and DeepSeek R1 Zero. Now, what is the means of zero? Zero means without supervised fine-tuning. Now, what is the supervised fine-tuning? Supervised fine-tuning is a powerful technique that is used to adopt the pretend large language model to specific the downstream tasks using level data. See, level data. That means it is using here reinforcement learning. DeepSeek R1, which incorporate the multi-stage training and cold start data before reinforcement learning. If I see the benchmark of that based on the OpenAI 011217 model, in the case of AI AMI, you can see here it will just top. It just reach the top positions of the float. You can see 79.8 in case of IME 2024 DeepSeek R1. In the case of code forces, you can see here it just don't have any different. It's slightly different on here. In the case of math 500, you can see here just it crossing this OpenAI 011217 model. That's mean in some kind of benchmark, DeepSeek R1 right now in the top-notch quality. Now the question is, what is a reasoning model? Reasoning model is working in a base model. We have one base LLM model. So DeepSeek R1 is a reasoning model built on foundation of DeepSeek V3, which one is nothing but another model, previous model of DeepSeek AI. Like any good reasoning model, it starts with a strong base model, and DeepSeek V3 is exactly that. That's mean in here we having one base large language model, and you're going to passing here high quality reasoning data inside the reinforcement learning, and then we got in here one reasoning large language model. That's called the reasoning model in terms of DeepSeek. In the terms of training part, they actually following some sections that we present here. DeepSeek R1 Zero, which applies the reinforcement learned directly to the base model without any supervised fine-tuning data. That's mean without label data. And DeepSeek R1, which applies RL starting from a checkpoint fine-tune with thousands of long chain of thought COT example. Now, what is the chain of thought? Chain of thought is just writing come after the few short prompting. That's mean chain of thought is a prompting technique. If you want to learn about the prompting, you can go and check out the videos in the descriptions. So chain of thought is nothing but solving a problem step by step. See again, step by step. In the few short prompting, we're actually giving some example. In chain of thought prompting, we're giving that solving this problem step by step. That's called the chain of thought process. Then we have the distill the reasoning capability of DeepSeek R1 to small dense model. Now, what is the distillations? OpenAI already claimed that they distill their own network and try to building here these DeepSeek. Distillated means nothing but using here a big model, and as well as we have a small model. So a small model is trying to gain some knowledge from the big model and try to make it more. Okay, no problem. We'll discuss it later on. But distill means nothing but learning something from the big model. So in the terms of DeepSeek R1 Zero, they're actually using here reinforcement learning on the base model. Now, what is this base model? In the base model, they're actually using here reinforcement learning algorithm. And the algorithm name is Group Relative Policy Optimization, which is nothing but one advanced version of PPO algorithm. PPO algorithm. This is nothing but a reinforcement algorithm, also stand for proximal policy optimizations. In order to save the training code cost of RL, we adopt here group relative policy optimization in the paper they actually mentioned. That's means see training cost. In order to remove the training cost of reinforcement learning, because in the PPO we actually training here two model. One is a policy model Another one is called value model. So first you need to learn about that what is PPO. Then you're going to do some difference between this group relative policy optimization and try to building this one. Okay, that's not a problem here. Okay, let's go on here and try to understand here the PPO first. So PPO stand for proximal policy optimizations. So in the PPO, we having two network. One is called policy network. Another one is called the value functions. So policy network taking an state as the input and giving here an action as output. So let's say you have the four output layer. So based on that, it will give me here four state of the probability. You can see A1, A2, A3, and A4. That's nothing but probability of that. In the value function, we passing here state and the actions, and after that it will return here one key value, and key value is nothing but consists of the state as well as the actions. Now what is the state and what is the actions and what is this key value and what is the reward? It's nothing but coming in the terms of reinforcement learning. So what is the reinforcement learning, right? Reinforcement learning is a concern with how an intelligent agent should take action in an environment to maximize the cumulative reward. See, cumulative reward. So let's say in our image, you can see here we having agents as well as we having one environment. So in the environment, we having some state, and in the environment, we can take in the actions using this agent. And based on the action, it will give me some kind of reward. That's called the reward model. So reward model is nothing but one transformer model itself that actually using in this case of DeepSeek. Now let's take one example and try to understand here the reinforcement learning using one grid world. So in our grid world, we having one dog. That's my dog that is available in my house. My favorite dog is called Tiger. Okay. So this is the dog, and the dog is nothing but an agent. It's an agent. Agent is nothing but a dog. Now the dog can move here, or the dog can be moved from here to here, here to here, and try to achieving this meat because my dog Tiger is like to eat the meat, right? So after getting here the meat, you'll get some reward. Let me see. We having some agents. Agent is dog, and we having a state. State is nothing but our coordinate, x and y coordinate, and we having some actions. Dog can go up, dog can go down, dog can go left, dog can go right, like that, right? This is nothing but our actions, are nothing but the four directionally connected cell, right? And now based on that, it will getting some reward. Let's say if it is getting here this meat, it will getting here the 100 reward. And if it go to this brome, okay, तो मार तो खाएगा ना भाई, तो reward is nothing but -1. And if the dog is go to this butt up, because my dog is not trying to is fright of the water, okay, because this is the winter seasons, it will getting here the -10. So dog is try to obviously reaching here all the possible paths to try to reaching here this eating this meat, right? So let's try to clean the screen first. Here we go. That means, see, let's say dog is trying to go from here to here and again here. That means it will getting the reward as a -10. Now again, dog is trying to move from this direction, let's say this direction, and now it is getting here the broom. And reward is nothing but the -1. Now dog is trying to move from this position to these positions. Now reward is getting 0. That means how the dog is getting here the empty cell because he is not finding here any meat. How can he eat? Again, he is hungry, right? So it will getting here reward as 0. Now dog is trying to reaching from this position and try to achieve this meat. Okay. Now dog receive here plus 100 as a reward. That's based on some actions. Based on some action, it will giving some reward. Giving some reward. Okay. But see, dog can also going from this direction as well. Or maybe he can going from this direction or this direction or this direction, like that. Okay. That's when dog can go to and elaborate here possible path, that's called the policy. Or you can say list of possible path. Possible path. It's also called the trajectories. It's also called the trajectories. So what is trajectories? Trajectory is nothing but the list of policy. Now you can see that is how reinforcement learning is actually work. Now let's see what are the similarity between the PPO algorithm and the GRPO algorithm equations. So if I see the equation of the PPO, it having also one current probability state, and also you can see here it having also one previous probability. So this current probability is nothing but taking a state as well as it will giving some actions. Okay. So in the old, you can see here it also having a state as well as it having some actions. The same case on here in the GRP algorithm, it also having one questions, and based on this question, it will giving some answer, I mean output. Same thing on here on the previous iterations. Also in this case, you can see here, it's also having one advantage term, also called the gain term. So in the same case of the GRPO, it also having one advantage term. So in the PPO algorithm, it also having the clipping technique, but in here it also having the clipping technique, not but actually it also have the clipping technique. Just actually a change based on the output. You can see taking one state, it will giving here on actions, okay, and you can see here to taking one question and it will giving here on output. That's the basic difference, because this is working in the case of reinforcement learning and this is working in the case of large language model. Now let's try to elaborate more this proximal policy optimization and try to see what are the math behind this PPU algorithm. So now let's see what are the math behind these proximal policy optimizations. So in here you can see here the term this called pi theta, and taking one state and based on state it will give me here one actions, and in the same case here it is nothing but the previous probability, okay, and also you can see here it having that abundance term. So let's take one example. We having 100 iterations, so 100 is the last one. So let's say in the 99, that's the previous iteration, we got in one policy value of the 0.2. Okay, we don't have any gain on here. Now in the last time we can get here some gain of the value, because after that we getting here some kind of predicted value, right? So in after the iteration number 100, we got in here the policy value as a 0.4. This is 0.4 and gain as a 10. Now if I divide in this iteration number 100 to 99, and we got in here a value called 20. Okay, so 20 we can simply going to putting this value inside our value neural network, and this term is called the surrogated objective function, because this formula is called the surrogated objective functions. So here at is nothing but action at time step 1 or time step 2 or time step 3, and st is nothing but the state of the time step, various time step. It can be the 1 to 100 or it can be the 1 to 1000 as well. And also at is nothing but called the gain or the advantage term in the case of proximal policy optimization. Now, what happens if the previous probability is nothing but the last value or having some low number of value? What happens on these cases? So let's take one example. Let's say the current value is nothing but 0.4 and the previous value of the time step is nothing but called 0.001. If we divide them, we having one big number, and as well as if we multiply them with the gain value, still it's a still big number. So it's not a good choice to passing this value into one value neural network, because it has large number of value, right? Obviously it gives me some kind of problem, as well as you're taking much more amount of time, as well as you're taking a much more amount of memory. So it's not a good choice to pass in this in one neural network as a big number. So we have the image of the Ganpati Bappa. So let's say Ganpati Bappa Moria. So let's go next. Let's go on the next slide. So we have our current probability. This is called the current probability, and this is called the previous probability. Now in the example, we see that our previous probability is nothing but very, very low. So let's say we know that the probability is nothing but start from 0 to 1. So you can see 0 to 1. So let's say I'm taking some lower value of the both negative side and the positive side. Let's say I'm going to negative here 0.3 sections from 1. So we're having 0.7. And if I increase this value, let's say we're having 1.3. Now, if the value is lies between the 0.7 and 1.3, we can keep it. We can keep it. Now, let's say if the value is too small, make it 0.7. Make it 0.7. Now, you can see here, we overcome this problem on here. If I going this example, so in our case, the value is less than 0.7. That means it's automatically replaced with 0.7 in this case. Why? Because it's quite small than 0.7. Just make it 0.7. If it is too large, make it 1.3, because it may be happen in this case as well. If it is too large, we can also getting here one large number of value, so we cannot put it inside our value neural network. So that's why clipping is coming into the pictures, right? This is called the clipping. This is called the clipping. If I see if I see the formula of that, this is our actual formula of the policy, proximal policy optimizations, where we have the surrogate objective functions, as well as we having that advantage term or the gain term, and you can see here the clip and p nothing but policy, this one, and we having 1 minus epsilon and 1 plus epsilon, which on 1 minus epsilon is nothing but just we're taking the epsilon value as a 0.3 in the case of the examples. So in here we take it as a 1 minus epsilon. Now same thing, if it's between this 1 minus epsilon and 1 plus epsilon, just keep it. If it is smaller than 1 minus epsilon, keep it 1 minus epsilon. If it's larger than 1 plus epsilon, make it 1 plus epsilon, just like that, simple. It also have the advantage term. And after that, taking the minimum value from here, this is called the proximal policy optimization, right? Simple. So if I see what is the gain actually, because you already see that we discuss about every term just called surrogated objective function. We discuss about the how we can clipping this out, but we are not discussing about the gain or that bundle term. So what is the gain actually? Let's say we are going to passing here one value. I mean our neural network actually generate a value of 2. Now our actual value is nothing but 5. Actual value is nothing but 5. So what is gain? What is gain is nothing but the value is predicted minus the value is given by the neural network. So our gain is nothing but 3. Our gain is nothing but 3. That means these two is nothing but our neural network value. It is trying to reach out the 5. That means our 5 is going to increase the value. Let's say 2.1, 2.2, 2.3, 2.4 for each and every iterations. That's called the gain. So let's say we are going to then after the passing here on here, then after that it will increase the value. Let's say 2.1, 2.2 like that. Now what happened in the case of negative? So let's say our neural network is produce a value called 5 and our actual value is nothing but 3. So it will passing this value inside our value neural network, and our value neural network is trying to decrease the value because the gain is nothing but -2. It decreasing, let's say 4.9, 4.8, 4.6, 4.2 like that. This is called the gain, or this is called the advantage term in the case of proximal policy optimizations. Now let's combine all of the thing and see the formula of the gain. So you have the gain formula for here. So value given by the neural network, and this is nothing but our actual value calculated by path. This is nothing but the path, our predicted value, and we're simply going to using here the square root of that. This is the formula for the gain, or you can say the advantage term in the case of uh, reinforcement learning, right? Now let's combine all of the thing and try to see that what are the basic difference between these PPU algorithms and what is the difference between this GRP algorithm in terms of flowchart. So in PPU algorithm, it will taking one questions and it will passing to one policy model, and the policy model giving here on output, and this output is going directly to the reference model, the reward model, and nothing but an value model. So here this policy model and the value model is nothing but the trainable model, and the reference model and the reward model is nothing but one frozen model. That means it's already trained on that. So frozen means you can change the parameter on here. Then after that it will pass into a KL divergence and go to our reward model. Our reward. It will giving here some reward as well as it will giving me some kind of value. Then it will passing to inside our generalized advantage optimizations and passing here inside the advantage term. And the advantage term again passing this value to the policy network so that it can change in the value on that. That means how good our policy model is and how our reward model can get. Now in the case of GRP, you can see here same thing. We passing here questions to the policy model, and the policy model is try to generate some bunch of output. Now from the output, it will go to passing here the frozen model called reference model and the reward model. And the reward model is tied to generate some bunch of reward, and passing to inside one group competitions, and as well as it will produce some advantage term. How our model is. Now this advantage term is directly passing to the policy model. Now see advantage, if you got here a good advantage, that means policy network is good. If we got in here one best reward, that's mean our policy network is actually working fine. Now that's mean we need to also creating here some kind of reward model or the best reward model. You need to getting here some best policy network value. Now if I see the difference between the PPU and the GRPU, you can see that in the PPU training here model two times. One is the policy network model and another one is called the value model. But in the case of GRPU, we don't have any value model. That's when our time is less in terms of PPU algorithm. So that's why GRPU actually algorithm used in the case of large language model, the DeepSeek. So this is one high level overview of the difference between the PPU algorithm and the GRPU algorithm. Now you can see that we need to having one high quality reward model. So in the DeepSeek paper, they already actually mentioned about this one. In the reward modeling, DeepSeek uses a role-based reward system that mainly consists of two types of reward. First one is called the accuracy reward, second one is called the format reward. For example, in the case of math problem with deterministic result, the model is required to provide the final answer in a specific format. While we are solving any math problem, to giving the answer in kind of format so that you can get here the best result or best mark. Same thing in the case of lead code problem, a compiler can be used to generate feedback based on predefined test cases. It can be the brute solutions or it can be the optimal solution. That's mean result should be the correct. So if the result is correct, we can get in here some kind of accuracy reward. Now what about the format reward? So in the case of format reward, the process of the thinking is happen. It's between the think tag. So they're actually giving here one example in here. A conversations between user and the assistant. The user asked a question and the assistant solved it. The assistant first think about the reasoning process in the mind and then provide the user with the answer. With encloses some kind of tag, let's say think tag, when he thinking that, and answer tag is nothing but when he answered that. Not he, it should be it. Okay. So same thing in the reasoning process here. And also you can see here it will taking one prompt as a taking for the users, and also it will giving you the some response based on the assistance, and the prompt will replace with some specific reasoning questions during the training process. If I see the comparison of DeepSeek R10 and OpenAI O1 model on reasoning little benchmark, we see that we having on graph, in the x-axis we have the steps, in the y-axis we have the accuracy. So when the stability increases, accuracy is also increases in the case of R10 model. You can see here accuracy is also increases, and sometimes it will actually crossing the baseline of the OpenAI O1 model. You can see here this red line is nothing but our DeepSeek R10. It also crossing here this green line as well as it's crossed the pink line in the case of reasoning related benchmark. That's mean you can see that how DeepSeek crossing all of the things in the OpenAI O1 model. DeepSeek R10 also introduced here a self-evaluation process, which one is nothing but an reinforcement learning technique that can dive a model to improve its reasoning capabilities autonomously. That's mean it will try to revisit the thinking process or revisit the answer and try to correct it by own. That's called the self-evaluations. Now let's see this graph. In the x-axis, we have the step, number of step, and in the y-axis we have the average length per response. So when the number of steps is increases, same thing in the case of y-axis, the average length per response is also increases. You can see on here. That's mean DeepSeek R10 naturally learns to solve the reasoning tasks with more thinking time. That's why self-evaluation process is also important in the case of DeepSeek R10. Now, the DeepSeek R10, it have the self-evaluation process, right? It's called the reflections because this is a behavior like reflections. So here the model revisit and re-evaluate it previous step, and the explorations of alternative approach to problem solving arises the spontaneously. That's when you can see here the DeepSeek can also revisit his previous step, revisit his previous answer, right? This is called the aha moment of DeepSeek R10. It's also one important moment, right? Aha moment. Now let's go on the next slide. So in the next slide, we're having one solving some example questions. You can see here we having one question and try to solving this one. And you can say, wait, wait, wait. That's an aha moment I can flag here. And you can see here it will revisit this thing and try to solve this problem again and try to make it correct. This is also one important feature in DeepSeek R10. Obviously, DeepSeek R10 a good model, but it's also having some drawback. The first drawback is called the poor readability. Second one is called language mixing. Because of it using the reinforcement learning as well as it using here the chain of thought prompting. That's also one great problem in the case of language mixing. Now, how can you design a pipeline and how can you training here on DeepSeek R1? So it having some four stage in the case of DeepSeek R1. First one is called the cold start. So in the cold start, they collect such data to explore the cerebral approach using few short prompting with a long COT. I mean, few short prompting is nothing but giving some examples to the large language model. And large language model is try to solving this problem based on the example. And also it will giving here some long types of chain of thought prompting examples, directly prompting the model to generate details answer with reflections and verification. Reflection is nothing but called the self-evaluations, and the verifications gathering DeepSeek R10 output is readable format and refine the result through the post-processing by human annotator. You can see it's called the cold start in the case of DeepSeek R1. And second one is nothing but called reasoning oriented reinforcement learning. So in the reasoning oriented reinforcement learning, they actually using here some large scale reinforcement learning training process as employed in DeepSeek R1. This phase focuses on enhancing the model reasoning capability, particularly in reasoning intensive tasks such as coding, mathematics, and science and logic reasoning. Same thing in the case of the reasoning oriented model. They actually using here the proportion of target language what in chain of thought prompting. The third training process is called the rejection sampling and the supervised fine tuning. You know that what is the supervised fine tuning, right? Supervised fine tuning is a powerful technique that is used in the case of patent large language model to adapt the downstream tasks using the label data. So in here, they're actually using here reasoning data and the non-reasoning data. So you can read it from here. It's not a big deal. It's really easy to read. So I'm not going to discussing about here it here. You can just read it here. I'll give this paper link to the descriptions. The fourth one is called the reinforcement learning for all of the scenario. You can read it from here. The fourth one is important. It's called the distillations. Now, what is the distillations, right? Model distillation in machine learning is a technique used to transfer knowledge from a large, a complex model, often called the teacher model, to a smaller, simpler model, also called the student model. Let's say I am unable to solving here any math problem. Obviously, I go to the teacher, right? So same thing actually happening in the case of distillations. So the goal is to creating a smaller model that retain much of the performance of the larger model while being more efficient in terms of computational resources, memory uses, as well as the inference speed. That means they're actually using here one base model or the large language or large model and try to creating here a smaller model as well, which one is computational speed or it will using here some less kind of memory. Also, the training process is also speed. So this is called the distillation. So in the case of distillations, they're actually using here two model. One is called the Quen 2024B and the Llama, obviously from the Meta 2024, using 8K sample curated with DeepSeek R1. That's when DeepSeek R1 is using the model of the Quen and the Llama. But recently, OpenAI told that they actually distillated their model, I mean the OpenAI model. Distillation is nothing but one kind of stolen something from the others, right? Because we know that distillation is something going to making here one a small model, just like the bigger model, right? In the same in a low kind of process or low process or low in a low time scenario, right? This is called the distillations. So, what are the DeepSeek R1 distillated model? The DeepSeek R1 distillated model are smaller, more efficient version of the larger DeepSeek R1 model created through a process called the distillations. So, distillation involves the transferring the knowledge and reasoning capability of the larger, more powerful model in the case of DeepSeek R1 into a smaller model, right? We already know that what is the distillation is. So the paper actually open source a several distillation model. That's kind of model actually using here in the case of distillations. One is called DeepSeek R1 distillate, Coin 1.5 billion parameter. Then the distillate of the Coin 7 billion, Coin 14 billion, Coin 32 billion, Llama 8 billion, and Llama 70 billion. This is nothing but the distillated model on here. They're actually used by the DeepSeek R1, right? And you can see that if we see the model evolutions in the case of distributed format, you can see that in the case of AI, ME, and the math, you can see what actually happening in this case of here. in the case of distillations. Okay, you can see for the GPT 4.0, the value is nothing but 9.3. But in the case of here DeepSeek R1 distributed, the coin 1.5 billion, it's nothing but 28.1. You can see the benchmark in the paper. Okay, that's not a big deal to see the difference between them. Okay, now you can also see the in the case of evaluations. If I see in the English language, you can see that Open AI model is nothing but 91.8, and this is nothing but called 19.8. Quite similar, but in the case of simple Q, you can see here this model is also good OpenAI model. But in some kind of terms, DeepSeek R1 is also owning here. You can see here this kind of case, this kind of case, this kind of case. And if I see in the case of code, just like say code forces, you can see here it also increases, it's also increases, it's also increases. Okay, in some kind of benchmark, DeepSeek is right now in a popular model as well. In the case of DeepSeek R1 and other representative models, you can see here Claude 3.5, GPT 4.0, DeepSeek B3. DeepSeek B3 is nothing but their old model, right? I mean their base model. Now, what is the summary of this DeepSeek R1 paper? So they're actually using here pure reinforcement learning. No pretending. The AI learns just like humans by practicing and getting feedback using something called the group relative policy optimizations. It tested multiple solutions to pick the best one, right? You already know that what is the group relative policy optimizations. This is an reinforcement learning algorithm as well in top of PPO algorithms. The second one is a smart learning step. DeepSeek R1 learn step by step. One is called zero shot learning, no help from the humans because it learning himself. Then a little data is cold start and reinforcement learning. Cold start, we see that they actually collected some data from coding, mathematics, physics, chemistry, like that. And fine tune focused on reasoning. Okay, is nothing but a good thing because it using a base model and try to giving here some kind of reasoning data, not the non-reasoning data. Then we have the unique reward system. Okay, unique reward system because it actually using here two reward system. It's called the accuracy, and another one is called the formal reward. Also, they're actually using here another kind of reward system for the language mixing as well. Okay, I mean three kind of unique reward system they're actually using in these cases. So it doesn't aim for the correct answer, but it also gets reward for the showing it step by step thinking. This way it actually doesn't split up the answer but explain how it is to the air. Okay, the fourth one is really important. Is my favorite, that's called aha moment. Because see, DeepSeek is also revisited its previous step and try to solving this problem and try to solve this problem more uniquely. I mean giving here some kind of best result for that. Okay, so the crazy part, the AI actually stop itself and say wait, let me rethink. Yes, that's really a crazy thing. DeepSeek can actually stop himself itself, so not himself itself, and say wait. He can wait, and when it feels something it's wrong, it's like human having self-realizations in between solving a problem. They have made mistake. Yes, this is one really great technique they actually use in the case of DeepSeek, just like the human. Okay, and the fifth one is called super efficient. They took knowledge from the huge model, just like 17 billion parameter, I mean llama, and sequence it into a small model of tiny 1.5 billion. It's really a good approach, okay, in terms of memory, in terms of times. So, but you still think like a genius imaging fitting a supercomputer in our phone, right? The result beat 96.3 of human coder. This is really an um, yeah, it's really true. Score of 79.8 of AI ME advanced math, obviously. Achieved 19.8 in a general knowledge test, and all this using less computing power. You can see less computing is tiny 1.5 billion parameter. In the llama it has 17 billion parameter, right? And you can see the price is super cheap. You know that this is nothing but input token, output token, and compared with this OpenAI is crazy rate. Really a crazy rate. Is the end of the OpenAI? I don't know. Is the end of the OpenAI or not? Maybe Sam Altman is coming with a new model as well. But yes, we learned more thing about the DeepSeek. See, it have the how moment, it have the self realization just like the human, right? Right? Just like the human of the AI, same thing, right? So that's all about the DeepSeek R1 paper explanations. So in the next one, we're trying to creating rack system using DeepSeek R1. Okay. So thank you and bye bye. And also one more thing, subscribe my channel, share with your friends, and now bye bye.